is equal to R1 plus R2, or C1 C2 is equal to mod of R1 minus R2. In this case, the two circles touches externally. In this case, the two circles touches internally. Suppose C1 C2 equal to R1 plus R2. R1 plus R2. Two circles touches each other externally, and the point of contact, this divides C1 C2 on the ratio R1 is to R2 internally. Suppose C1 C2 equal to mod of R1 minus R2. The two circles touches each other internally, and the point of contact P divides C1 C2 on the ratio R1 is to R2 externally. Common tangent S1 equal to 0, common tangent there also S1 equal to 0. Next, case 4. If mod of R1 minus R2 is less than C1 C2 is less than R1 plus R2. Mod of R1 minus R2. Circle S equal 0, this is S dash equal to 0. So this is C1 and this is C2. C1 and C2. C1, C2, suppose this is, let it be some 10 units. R1 is R1. R1 is, this is R1. 6 units. R2 is some 7 units. 7 units. That means total R1 plus R2 is 13 units, and C1 C2 is only 10 units. So the gap is 3 units. So if mod of R1 minus R2 is less than C1 C2 is less than R1 plus R2. In this case, the two circles intersect each other. Mod of R1 minus R2 less than C1 C2 less than R1 plus R2. So the two circles intersect each other. In this case, number of tangents. So number of tangents. Number of common tangents, that is 2. Only these are direct common tangents, because the two circles lies on the same side of these lines. So number of common tangents, 2 common tangents. Next, case 5. Case 5. If C1 C2 is less than mod of R1 minus R2, C1 C2 is less than so this is center of a circle and this is the center of second circle. So this is the radius R1, and this radius is R2. Suppose C1 C2 is equal to 5 units and R1 this is R1 is 8 units, and R2 equal to, suppose R2, this radius is R2 is 5 units. Now the gap is here, it is 3 units. that is 3 units. So C1 C2 is less than mod of R1 minus mod of R1 minus R2. Sorry. Suppose you can treat as C1 C2, distance between the centers is, let it be some 5, and R1, so this is a radius, R1 is some 10 units, and R2 is, that is, let it be some 4 units. Therefore C1 C2, what is C1 C2? 5 is less than, so this is 10 minus 4, that equal to 6, that means what? This is 1 unit. So C1 C2 is less than mod of R1 minus R2. In this case, that is one circle lies completely inside the other circle. Inside the other circle. That means this circle, one circle lies completely inside the other circle. So in this case, number of common tangents. 0. Number of common tangents 0. Now, from this we conclude here C1 C2 is greater than R1 plus R2. C1 C2 is greater than R1 plus R2. One circle lies completely outside the other circle. So in this case, number of tangents 4. Second one, C1 C2 equal to R1 plus R2. Two circles touches externally. Number of common tangents 3. Next one, C1 C2 is equal to mod of R1 minus R2. So the two circles touches each other internally. Number of common tangents 1. And mod of R1 minus R2 is less than C1 C2, is less than R1 plus R2. The two circles intersect each other. Number of common tangents 2. Next one, mod of C1 C2 is less than mod of C1 C2 is less than mod of R1 minus R2. One circle lies completely inside the other circle. Number of tangents 0. Let example. First one. Find the relative positions. Find the relative positions of circles. Relative positions of the circles. X square plus y square minus 4x plus 2y minus 4 equal to 0, and x square plus y square plus 2x minus 6y plus 6 equal to 0, and find the number of common tangents. And find the number of common tangents. So this is the circle S equal to 0, this is S dash equal to 0. Center of circle minus z minus f, that is equal to, this is 2 comma minus 1. Radius equal to r1 root of g square plus f square minus c, that is root of 4 plus 1 minus of minus, that is 3. And the center of circle minus z minus f minus 1 comma 3. Radius is root of g square plus f square minus c, that is 6, that equal to 4 2. And find C1 C2. C1 C2 is equal to distance between their centers. Distance between their center, that is root of 2 plus 1 whole square plus minus 1 minus 3 whole square, that is root of, this is 9 plus 16, that is 5. Now you observe R1, R2 and C1 C2. Now what is C1 C2 is equal to 5. R1 plus R2 equal to R1 plus R2, that is 3 plus 2, that is 5. So C1 C2 is equal to R1 plus R2. R1 plus R2. Therefore, the two circles touches externally. So circles touches externally. Two circles touches each other externally. And the number of common tangents, number of common tangents is 1 2 3, 3 tangents. Number of common tangents. So there are so many cases. Suppose if we conclude C1 C2 is greater than R1 plus R2, 4 tangents. C1 C2 equal to mod of R1 minus R2, 1 tangent. So mod of R1 minus R2 is less than C1 C2, is less than R1 plus R2, intersect each other. So 2 tangents. And C1 C2 is less than mod of R1 minus R2, one circle lies completely inside the other circle. So number of common tangents 0. So in this case C1 C2 equal to R1 plus R2 touches externally, number of common tangents 3. Next one, find the internal center. Find the internal center of similitude. Internal center of similitude of the circles x square plus y square plus 6x minus 2y plus 1 is equal to 0, and x square plus y square minus 2x minus 6y plus 9 is equal to 0. Internal center of similitude. Center of circle minus z comma minus f minus 3 comma 1. Radius r1 is root of g square plus f square minus, that is 3. Center of the circle minus z minus f 1 comma 3. Radius root of g square plus f square minus c, that is 1. Now C1, C2 is equal to, C1, C2 is distance between their centers, that is minus 3 minus 1 whole square, 16 plus 16 plus 1 minus 3 whole square, that is 4, that is root of 20, root of 20, and R1 plus R2 is equal to 3 plus 1, that is 4, which is root 16. So this is C1, C2 is greater than R1 plus R2. R1 plus R2. C1, C2 is greater than R1 plus R2. Therefore, that means what? The two circles are like this. Therefore, internal center of similitude exists. But in general, what I am saying is, this is not compulsory. Suppose you have to check whether internal center of similitude exists or not. Suppose if the two circles intersect each other, in this case, the internal center of similitude does not exist. That's why just we have to check the nature of the circles, whether internal center of similitude exists or not. So clearly C1, C2 is greater than R1 plus R2. Therefore, internal center of similitude exists. So the internal center of similitude, this is ICS. This divides C1, C2 in the ratio R1 is to R2 internally. R1 is to R2 internally. That is equal to C1, where C1 is minus 3 comma 1 and C2 is 1 comma 3. R1 is to R2 is R1 is to R2 is equal to 3 is to 1. Now the formula is mx2 plus nx1 by m plus n, comma my2 plus ny1 by m plus n. Now this is m is to n. So that is equal to here. This is x1 y1, x1 y1, this is x2 y2. x2 mx2, that is 3 plus nx1 plus nx1, that is minus 3 by m plus n, 4. Next my2 is, that is 9. my2 plus ny1 is 1 by 4, that is equal to 0 comma 5 by 2. This is internal center of similitude. Sound was next one. If the circles x minus 1 whole square plus y minus 3 whole square is equal to r square, and x square plus y square minus 8x plus 2y plus 8 is equal to 0 intersect in two distinct points. Intersect in two distinct points. Then first option 2 less than or less than 8. Next 3 less than or less than 9. Next r greater than 2. 0 less than or less than 8. Circles. The circles intersect in two distinct points. Center of circle 1, 3, the R1 is R. Center of circle minus Z minus F, 4, minus 1, and R2 equal to root of 16 plus 1 minus 8. That is equal to 9. Root 9, that is 3. So this is R1 minus R2 is less than C1 C2 less than R1 plus R2. Where C1 C2 equal to C1 C2 distance between their centers, that is root of 9 plus 16, that is 5. So this is R minus 3 is less than 5 is less than R plus 3. So this is R minus 3 is less than 5 implies R less than 8. Next one 5 less than R plus 3. Therefore this is 2 less than R. So 2 less than R and R is less than 8. So these two implies 2 is less than R less than 8. So in our material level 1, so we have to do 51 to 72 problems. In the level 1 class work at the same time homework, so we have to discuss each and every concept, and also I discuss some problems in this one. Once you go through the notes perfectly and solve these problems, so then only you feel very, very easy by solving these problems. Next one. Next problem. Show that the circles x square plus y square minus 6x minus 2y plus 1 equal to 0 and x square plus y square plus 2x minus 8y plus 13 equal to 0 touches each other and find the point of contact and find the point of contact and find the equation of common tangent at their point of contact. Show that the two circles touches each other and find their point of contact and find the equation of common tangent at their point of contact. Center of circle minus z comma minus f, that is 3 comma 1. Radius g square plus f square minus c, that is 3. Center of circle minus 1 comma 4. R2 g square plus f square minus 13, that equal to, this is 4, 2. And the distance between their centers C1, C2 is equal to, C1, C2 is root of 3 plus 1, 4 square plus 1 minus 4, that is minus 3 whole square. 16 plus 9, that is equal to 5. Therefore, C1, C2 is equal to R1 plus R2. R1 is 3, R2 is 2. So, that is 5. Therefore, the two circles touches externally. Two circles touches each other externally. So, this is C1, this is C2, R1, R2. So, this is the common tangent. So, the point of contact call it P, divides C1, C2 in the ratio R1 is to R2 internally. Point of contact P divides C1, C2 in the ratio R1 is to R2 internally. Where C1 is 3 comma 1 and C2 is minus 1 comma 4 and R1 is to R2. R1 is to R2 is equal to 3 is to 2. So, this is M is to N. So, this is x1 y1. Therefore, point of contact P equal to M x2 plus N x1 by M plus N, comma M y2 plus N y1 by M plus N. So, the point of contact P is equal to x1, y1, x2, y2. x1, y1, this is x2, y2. mx2 is minus 3 plus nx1 is 6 by m plus n 5 and my2 is 12. my2 plus ny1 ny1 is 2 by m plus mx2 my2 plus ny1 plus 2 by 5. Therefore, that is 3 by 5, comma 14 by 5. So this is the point of contact. Now at that point I have to find the common tangent. You can take any one circle. I am taking the circle S equal 0. S is x square plus y square minus 6x minus 2y plus 1 equal to 0. Now the point is 3 by 5 comma 14 by 5. Now equation of common tangent is S1 equal to 0, where S1 is xx1 plus y by 1 g into x plus x1 plus f into y plus y1 plus c equal to 0, where x1 is 3 by 5 comma 14 by 5. So that is 3 in x into 3 by 5 plus y into 14 by 5. G value, where g is minus 3 into x plus x1 3 by 5 plus f into f is minus 1 into y plus y1 is 14 by 5 plus 1 is equal to 0. So this we have to calculate. S1 equal to 0. So finally you get 4x minus 3y plus 6 equal to 0. So that is the equation of common tangent. 4x minus 3y plus 6 equal to 0. Try the next problem. Find the equation of circle which touches the circle x square plus y square minus 2x minus 4y minus 20 equal to 0 externally at the point 5 comma 5 with radius 5. with radius 5. Find the equation of circle which touches externally the circle at the point 5 comma 5. The radius is 5. Radius of given circle, this is 5. Now this is C1. C1 is equal to 1 comma 2. Radius R1 equal to root of G square 1 plus 4 plus 20. 25, which is 5. 5. And center of second circle C2 equal, let it be some H comma K center. So R2 is also equal to 5. The two circles touches externally. So this is the radius R1 is 5, R2 is also equal to 5. Implies the point of contact. This point is the point. Is the midpoint. The point is midpoint, and also the point is given 5 comma 5. 5 comma 5. Therefore, the point P is equal to midpoint of C1 C2. Since R1 is equal to R2, and also the two circles touches each other externally. So what is the point of contact? 5 comma 5 is equal to midpoint. Midpoint is C1 C x1. So the point is 1 comma 2. So this is H plus 1 by 2 comma K plus 2 by K plus is. So H plus 1 is equal to 10. H equal to 9. Like K plus 2 is equal to 10. Therefore K is equal to 8. Therefore center of circle is H comma K, that is 9 comma 8 with radius 5. So center and radius. So equation of circle. Equation of circle is x minus a whole square plus y minus b whole square is equal to r square. Equation of circle x minus a whole square plus y minus b whole square is equal to r square. So that is x minus 9 whole square plus y minus 8 whole square. R is 5. R square is 25. Next problem. Next one. Find the equation of circle which touches the circle x square plus y square minus 4x plus 6y minus 12 is equal to 0 at minus 1 comma 1 internally with radius root 2. Sorry, with radius is 2. With radius 2. find the equation of circle which touches the circle this internally at the point minus 1 comma 1 with the radius is 2. Radius 2. So this is the center of circle. C1 is equal to minus z comma minus f, 2 comma minus 3. R1 is equal to root of 4 plus 9 plus 12, root 25, that is 5. There you have to find the center. We don't know the center. Radius is equal to radius. Radius is R2, that is 2. So the two circles touches each other at the point of a P, minus 1 comma minus 1 comma 1. Minus 1 comma 1. Let the center of second circle is, let it be h comma k. Center of second h comma k. So two circles touches each other. Therefore, the point of contact divides C1 comma C2 in the ratio R1 is to R2, R1 is to R2 externally. R1 is to R2 externally, where C1 is 2 comma minus 3 and C2 h comma k. R1 is to R2 is equal to 5 is to 2. 5 is to 2. Therefore, the point of contact is equal to mx2 plus nx externally. So, mx2 minus nx1 by m minus n, comma m y2 minus n y1 by m minus n. That is, so this is m is to n. M is to n, it is x1, y1, it is x2, y2. So, m x2 means that is 5h. M x2 minus n x1, that is 4, by m minus n, 3, and m y2, m is 5k, minus n y1, minus of minus, that is plus 6 by 3. And the point of contact is already given, minus 1 comma 1. Point of contact is minus 1 comma 1. Therefore, 5h minus 4 by 3 is equal to minus 1. 5h minus 4 equal to minus 3. 5h is equal to 1. H equal to 1 by 5. H is 1 by 5. And next 5k plus 6. 5k plus 6 by 3 is equal to 1. So, 5k plus 6 is equal to 3. Therefore, k is equal to minus 3 by 5. Therefore, the center of the second circle is center 1 by 5 comma minus 3 by 5. 3 by 5 with the radius already given 2. Radius is given 2. So, center of the circle is 1 by 5 comma minus 3 by 5. Radius is 2. Radius 2. So, equation of circle is x minus a whole square plus y minus b whole square is equal to r square. So, this is x minus 1 by 5 whole square plus y plus 3 by 5 whole square, r square is 4. By expanding this, so you get the standard form. Next question.